Now the goal of this exercise is to create a geofence for each place we've added in the database, and then register those geofences and start listening to any entry or exit triggers. So to help keep things organized, let's put all this geofencing logic in a class that we'll call Geofencing. Now as a warning, this might feel like a long exercise with quite a handful of steps to go through, but all the steps complement each other. So just take it one step at a time, and once we have all the pieces, we hook everything together and let the magic happen. So here's an overview of what we'll be building. First, we need to build geofence objects using their longitude and latitude and a predefined radius. Then we'll store all these geofences in a list and then register those geofences. Now to register them, we need to create a geofence request object from that list of geofences. We'll also need a pending intent that will specify which intent to launch when the geofence entry or exit event triggers. In our specific case, we'll be using a broadcast receiver in our pending intent, which means that whenever the device enters or exits any of the geofences, well, the onReceive method in our broadcast receiver will run, so we can implement our logic all there. Having all these components ready, we then start registering geofences by passing in the geofence request and the pending intent objects. And along with that, we'll add in our Google API client that we created in our very first exercise. And with those things done, voila! Watch as the magic happens as you walk your device into any of the geofences you've created. With that setup in mind, let's get started in the code. So first, create the geofencing class. Then add in a context and a Google API client, and refer to them in the constructor. I've also added a geofence pending intent member variable and a geofence list variable that we'll be using later. Go ahead and import any classes that are needed. Then implement a public method called updateGeofencesList. With that method, given a place buffer instance, it goes through all the places in it, and for each place, it will create a geofence object and add it to a list. To create a geofence object, you'll need to call geofence.builder, where you'll set a few things. So first, you'll need to set a unique ID for this geofence. Let's simply just use the places unique ID from the places API, since this will ensure that it's unique for each place. Then we need to set an expiration duration in milliseconds. I've decided to set it here to be 24 hours, which means that if the geofence wasn't registered again in 24 hours, the location services will remove this geofence. Note that you can actually set this to the constant never expire. But be careful, because this means that the geofence will remain there forever even when you uninstall your app. So be very, very careful if you do decide to use this constant as the expiration duration. Since we're using the 24-hour lifetime, for a production quality style app, you should set up a job scheduler and register geofences every day. But for the focus of this toy app, we'll just focus on getting the functionality in for now. Next, we need to set the region in terms of longitude and latitude centers and a radius in meters. Here I've set my radius to 50 meters, which is a reasonable value for our purposes. Now to finish it off, the transition types are needed. And since we want to act both upon entry and exit transitions, we need to register it for both. Once the geofence object is built, we'll simply add it to the array list. Lastly, make sure you've imported all the necessary classes. And there we go. Now that we have this list of geofences, in the next video, we'll get to set those geofences to trigger a broadcast receiver whenever a transition occurs.